Problem 27, Quantum Mechanics. The question is, the ground state energy of a particle of mass m in the potential V of x is equal to h bar square beta by 6m x raised to 4, estimated using the normalized trial wave function psi of x equal to alpha by pi raised to 1 by 4 e raised to minus alpha x square by 2 is. In the question, the ground state energy of a particle in a potential V of x is asked using the normalized trial wave function. So using the normalized trial wave function, we have to evaluate the ground state energy of a particle in a potential. The potential is given. Here we have to use the variational principle. Using variational principle, we can find out the ground state energy of the particle using a normalized trial wave function. First, let us find out the expectation value of kinetic energy, that is equal to h bar square by 2m integral minus infinity to infinity d psi by dx all square dx. Psi of x is given in the question. Let us find out d psi by dx, that is equal to alpha by pi raised to 1 by 4 e raised to minus alpha x square by 2 into minus alpha x. This is d psi by dx. Therefore, the expectation value of t becomes h bar square by 2m integral minus infinity to infinity, then alpha by pi raised to 1 by 2 e raised to minus alpha x square, then alpha square x square dx. Let us take all the constants outside the integral sign. Now expectation value of t is h bar square by 2m alpha by pi raised to 1 by 2 alpha square integral minus infinity to infinity x square e raised to minus alpha x square dx. To evaluate this integral, use the integral which is given in the question. Use the result which is given in the question. Therefore, expectation value of t become h bar square by 2m alpha by pi all raised to 1 by 2 alpha square, then 1 by 2 alpha root of pi by alpha. Now we can see pi by alpha cancels. Now the remaining term is h bar square by 2m into alpha by 2, that is h bar square alpha by 4m. Therefore, the expectation value of kinetic energy is h bar square by 4m alpha. Thus we have evaluated the expectation value of kinetic energy. In the same way, let us find out the expectation value of potential energy, that is integral minus infinity to infinity psi star v psi dx. Here v is the potential which is given in the question. V of x equal to h bar square beta by 6m x raised to 4. Therefore, the expectation value of v is integral minus infinity to infinity alpha by pi raised to 1 by 4 e raised to minus alpha x square by 2. Now the potential h bar square beta by 6m x raised to 4. Then again psi alpha by pi raised to 1 by 4 e raised to minus alpha x square by 2, then dx. Now let us take all the constants outside the integral sign. Expectation value of v is alpha by pi raised to 1 by 2, then h bar square beta by 6m integral minus infinity to infinity x raised to 4 e raised to minus alpha x square dx. Again, to evaluate the integral, use the result of the integration given in the question. So expectation value of v is alpha by pi raised to 1 by 2 h bar square beta by 6m, then the value of the integral is 3 by 4 alpha square, then root pi by alpha. Here Again, root pi by alpha cancels. So expectation value of V is h bar square beta by 6m 3 by 4 alpha square, that is equal to h bar square beta by 8m alpha square. Thus, the expectation value of V is equal to h bar square beta by 8m alpha square. Once we obtained the expectation value of T and V, we can write the expectation value of Hamiltonian as the sum of these two. Expectation value of H is equal to expectation value of T plus expectation value of V, that is equal to h bar square alpha by 4m plus h bar square beta by 8m alpha square. Our next aim is to find out the unknown constant alpha in the wave function psi of x. For that purpose, let us take dou by dou x of expectation value of h and equate it to 0. And from that equation, find out alpha. Then substitute the value of alpha in the equation of expectation value of h. You will get the energy. Now dou h by dou alpha equal to 0 gives h bar square by 4m minus 2h bar square beta by 8m alpha cube equal to 0, or h bar square by 4m equal to h bar square beta by 4m alpha cube. Here h bar square by 4m cancels on both sides. You will get beta is equal to alpha cube, or the unknown parameter in the wave function alpha, which is equal to beta raised to 1 by 3. Thus we have evaluated the value of alpha. Once we have alpha, substitute the value of alpha in the equation of the expectation value of h, so that you will get an expression for energy. Expectation value of h is equal to h bar square by 4m alpha plus h bar square beta by 8m alpha square. Now what is alpha? Alpha is equal to beta raised to 1 by 3. Therefore, expectation value of h is equal to h bar square by 4m beta raised to 1 by 3 plus h bar square beta by 8m alpha raised to 2 by 3. This is equal to h bar square by 4m beta raised to 1 by 3 plus h bar square by 8m beta raised to 1 by 3. Therefore, expectation value of h is equal to h bar square by 4m beta raised to 1 by 3 into 1 plus 1 by 2. Now we can say that the ground state energy of the particle is then 3 by 8 h bar square beta raised to 1 by 3. Now from the given option D is the correct option.